So we have discussed how to send CGS system to MKS system, SI system. Just multiply it by 1000, you will get the SI system unit. Okay, here some examples are given. If density of gold in CGS system is 9.6 gram per centimeter cube, this is 24 carat. The conventional unit of density or purity is used in carat. 24 carat means 19.6 gram per centimeter cube. Okay, 24 carat. 22 carat, what is 22 carat? In 24 part of gold, 2 parts is different, 22 parts is gold. Density of gold in SI system, just multiply by 1000, you will get in SI system. But look at this, when you multiply by 1000, then you have to change the unit to SI system unit, density kilogram per meter cube. Okay, whenever you multiply by 1000, then you will get kilogram per meter cube. So conversely, if density is given in SI system, it can be converted into CGS system by multiplying with numerical 1 by 1000. Given in CGS system, SI system, just divide it by 1000, you will get in CGS system, means gram per centimeter cube. Always remember these units. If you don't change this unit, then the answer will be wrong. Okay, remember units of density. What is the unit of density? Simple thing. Remember the tomatoes, the 2 tomatoes. Are their masses same?
No.
Different type of gram, but their density is same. Then, tell me the definition.
The amount of
mass. Then
in per unit
volume. There are 2 physical quantity. What are these?
Mass and volume.
Mass and volume. 10 unit volume has mass, suppose 50 gram. Okay, 10 unit volume. 1 unit volume. What will be the 1 unit volume has mass?
5.
How do you get?
Dividing.
Yes, 5 gram. What you have done? You have done the unitary method actually. What is unitary method? You divided 50 divided by 10 units. So 1 unit has 5 gram. 1 unit volume will be 5 gram. So this will be the density, 5 gram. 5 gram in how much volume? In 5 gram
in 1
unit. In 1 unit volume. Okay. So that's why we have got this formula, M by V. Here V is the actual volume of the object, and M is the actual mass of that object when you measure the mass
of V.
Of V, yes. Then we have to find 1 unit. We have to find mass of 1 unit volume. So this is the formula. 1 unit it is. Understood? This is the formula. Now, how will you get the unit? Whenever you get some like this formula, just put the unit here. Unit of mass?
Grams.
Gram. Here this. Unit of volume?
Unit
volume. Unit of volume? In meter? Centimeter? Meter cube. Here you have to write centimeter cube because you are using CGS. Okay. Now you have understood what the unit of density, what is M by V, what is Y gram per centimeter cube. If you write in SI system, what is the unit of mass?
kg.
kg. What is the unit of volume?
m3.
M cube, not m3. So have you understood now? Probably you have understood this. Why M by V is come for density? Why unit is come in gram per centimeter cube? Mass is suppose we take half portion of this table. Now here, will the density will be same if you take whole the table, and if you take half portion of this table, will the density same or different?
It will be the same.
Will be the same because density means the matter contains in per unit volume. Understood? Per unit volume. Wherever we are taking this whole table or you are taking a small portion of this, we have to measure a unit cube. Okay. So in CGS system, mass is measured in gram and volume in cubic centimeters. Therefore, the unit of density in CGS system is gram per centimeter cube or gram centimeter inverse 3. In SI system, mass is measured in kilograms and volume in cubic meters. Therefore, the unit of density in SI system is kg per meter cube or kilogram meter inverse cube. very bigger, very large object, it may be a small object, it doesn't matter in density. In 1 unit cube, how much matter is there? That is important. Okay. Now we are coming determination of density of a solid by using a mirroring cylinder. Mirroring cylinder. Okay. We must know the mass and volume of the solid in order to determine the density of a solid. What? We have to know the mass and as well as the volume. The mass of the solid is determined very accurately by a physical balance. Let it be m gram. Okay. To find the volume, take a measuring cylinder and pour some water in it. Record the volume of water and the graduations marked on measuring cylinder. Let it be x cm cube. These are the graduation. We measure the volume in this technique in earlier class. Can you remember? The displaced water is equal to the volume of the object. Okay, the same technique. In regular object, you can just measure it by scale and you'll get the volume. But irregular body, this is a very convenient way. Okay, displaced water is equal to the volume of the object. And one more thing, that 1 milliliter is equal to 1 centimeter cube. That's why here the marks is 1 milliliter. So whatever, if you go to that classes, then if you review that, if you revise that, you'll get to know that. Now it is given now tie the given solid on a fine thread, so length is volume v cm cube. Okay, we have done this. Knowing the mass and volume of the solid, the density can be calculated by the formula mass per volume m by v gram per centimeter. M here m gram. Okay, here the volume v, the same technique used before. This is the formula. Determination of density of a liquid by using a density bottle. You see, petrol has different density and diesel has different density. Okay, so how can we measure liquid? Because if you pour liquid here, it will mix up. Here, you cannot then take out this liquid from here. You can make a specially designed density bottle of capacity 100 milliliter is used for finding density of liquids. It is a small glass bottle having a close-fitting round glass stopper at its neck. This is the stopper has a small capillary tube. When the bottle is completely filled, the some liquid and then stopper is inserted. Then the excess liquid rises through the capillary tube and comes out. This ensures that the bottle contains equal volume of liquid when filled with different liquids. Look at this. This is a stopper. There is a capillary tube. Suppose you pour liquid up to here. Okay. Then you just insert this stopper. Then excess amount of liquid will come out from this capillary tube. Okay. So it will always contain 100 milliliter of liquid, not more than that, because excess amount will come out from here. So accurate measurement. Now method. Wash the density bottle with distilled water and then dry it in hot air. Okay. After
why in distilled water?
Distilled water doesn't have any other minerals. In the density bottle with distilled water completely and then insert the glass stopper. Wipe the bottle dry from outside and fill its mass by a physical balance. First, you have to wash the bottle. Number 1, distilled water, so that there is no residue in the capillary tube. After that, you have to insert distilled water. Number 2, I am reading this. Number 2. In number 2, then you have to insert distilled water. Fill the density bottle with distilled water completely. Okay, fill it completely. Then some water will come out from here.
From the stopper.
Capillary tube, and you have to wipe it dry. Okay, then you have to measure the mass of this whole bottle containing the distilled water. Remember, okay, put the distilled water, then measure the mass of the system. Pour off the water from the density bottle and dry it in hot air. Okay, fill the density bottle with the given liquid, say kerosene oil, alcohol, brine solution, etc. Whatever the liquid you want to measure.
You can also put tap water.
Yeah, tap water. You can also put tap water if you want to measure the density. Okay. Insert the stopper and wipe the bottle dry from outside. Find the mass of the density bottle along with liquid by a physical balance. Again, you have to measure the mass of the whole system. Okay, the liquid and the capillary tube. First time the liquid is distilled water. Second time the liquid which you want to measure the density. Okay, mass of the empty bottle m gram. Okay. M gram can be without distilled water. It is not written here. Suppose you dry it first, wash it with distilled water, then dry it. Then you can measure the mass of this capillary tube. Empty bottle you just place in physical balance, you will get mass. Okay, this is not written here. Mass of the empty bottle. Mass of empty bottle plus water, distilled water, first process, M1 gram. Suppose M1. Okay. Mass of the empty bottle plus liquid. Liquid means which liquid you want to measure the density. Kerosene maybe, or maybe liquid. Mass of only water. Mass of only water, M1 minus M. Okay. Bottle, if M, bottle plus water, M1. M1 minus M. Okay. Now volume of 1 gram of water is equal to 1 centimeter cube. Volume of 1 gram of water, 1 centimeter cube. Then volume of M1 minus M gram water, how much will be? M1 minus M cm cube. If 1 gram of water is this much, this will have some result. Okay, whatever be the result, just they are alphabetically expressing it. Okay, M1 minus M, whatever, 10, 15, whatever it is. Cm cube. If one has this much will be this much. Okay, volume of the bottle, M1 minus M cm cube. Volume of bottle. Okay, volume of water is equal to volume of the bottle. Okay, why? Volume of the water here this much, so this will be the equal of volume of the bottle. Okay, volume of liquid, volume of water, we have got the volume of liquid. Also mass of only liquid, liquid plus bottle M2, only bottle has M, so M2 minus M is the mass of only liquid, M2 minus M gram. Density of liquid, mass of liquid divided by volume of liquid. Mass of liquid equal to M2 minus M. Volume of liquid M minus M. Same volume as the water. Okay. Just every step they have shown in here. If the mass of liquid is 40 gram and the volume of liquid is 50 cm cube, then density of liquid, mass of liquid divided by mass of volume of the liquid. Okay. 40 gram by 50 centimeter cube. Understood? What?
1 gram of water is equal to 1 centimeter cube. So,
Okay.
1 milliliter of water is also equal to 1 centimeter cube. So, 1 gram is equal to 1 milliliter.
1 gram of water is equal to 1 centimeter cube. And 1 centimeter cube is equal to 1 milliliter. So, milliliter, I'm sorry. So, 1 gram is equal to 1 milliliter. Is it true? Yes. Is it true? So, okay, it is not given here. Very important. 1000 gram is equal to
1 liter.
1 kg equal to 1000 gram is equal to 1 kg is equal to 1000 milliliter approximately. Water, only water. Only water. So 1 gram of water is equal to 1 milliliter. 1 milliliter is equal to 1 centimeter cube. Okay, this is not given. It should be given. Okay.
But for distilled water.
Yes, only for distilled water. But you can also consider the common water also. Most of the time, it is very minimal differences there. Okay, distilled water, you can consider 1 milliliter is equal to 1 gram. But 1 milliliter of blood is not 1 gram. It is more than 1 gram. Okay, only for water. Remember this. Okay. Variation of density of liquids and gas with temperature. All forms of matter, solids, liquids, and gases expand on heating and contract on cooling. Okay, we have got in chemistry class.
That is called thermal expansion.
But in case of solids, the expansion with the rise in temperature is so small that it is negligible. So we can assume that the minor changes in temperature by 20 degrees Celsius to 40 degrees Celsius, the density of solid does not change. Now, in case of liquids and gases, there is a large change in volume with the rise in temperature, but the mass of a gas or liquid remaining constant. If their volume increases with the rise in temperature, then the density of them will decrease. Understand? Density of solids hardly changes with a rise in temperature by 20 degrees Celsius. What is the coldest day? Means in cold days, what is the temperature here? it is about 12 degrees Celsius, 13 degrees Celsius in December. Okay, in December at night, it comes to 13, 14 degrees Celsius. And in July, what is the temperature in the at noon?
35.
35. How much difference? Almost 20 degrees Celsius of differences. So, in that case, in case of solid, the increase of volume is negligible. Very little amount of increase in volume in case of solid. Now, what happened? Look, suppose these two atoms, suppose three atoms are there, here, here, here. Okay. When you heat it, then what happened? The intermolecular distances between all these atoms increases like this, like this, like this. Now, before increasing the temperature, how many atoms are there? Suppose these are molecules, 6. Okay, so total mass is m. Suppose if m is mass, then total 6m. Suppose. Okay. Now after heating, how many molecules are there?
6.
6. What will be the mass? Total mass 6m. Now volume.
Volume will change.
Volume will change. Now see, volume increases, but what will happen to density? M by V. Here also M by V. Here also M by V. Suppose 6m, 6m. Okay. Now here V this much. Here V greater than this. Suppose V dash. It increases. Now density will be which one will be more and one will be less?
This one will be more.
Density. Because
the volume has increased.
Volume has increased. The denominator increases. When denominator increases, the value decreases. The density, which will have more density?
This one will have more density.
Yeah, this will have less density. So when we heat something, intermolecular distances increases. V increases. So density decreases. Conversely, if we cool something, okay, then it will shrink. V will decrease, then density will increase. So this is the main fundamentals law, that when something is heated, the density decreases. Now in case of balloon also, suppose this is a balloon. Okay, suppose here m is the mass of the air. Now we suppose put it in hot water, then it will increase. Because why it will increase? Because intermolecular space.
How, if you put the balloon in hot water, the balloon will burst.
Suppose you put it in warm water, not hot water. Okay, warm water, then it will not burst. Just it will increase. It will the inflate itself. Now the volume again increase. Now what about the mass of this air? Will it increase or decrease?
It will
remain same. But again V becomes V dash, increases. Again density will decreases. Okay, so why density decreases when it is heated? For example, if a liquid X has a volume of 50 centimeter cube, okay, 50 centimeter cube, and mass 70 gram at 0 degrees Celsius. 0 degrees Celsius means when the water freezes. Okay, so water becomes ice. 0 degrees Celsius. Okay, it's very cold. Such that its volume at 100 degrees Celsius is 55 centimeter cube. Then look at this. X has a volume 50 centimeter cube and 70 gram. How much? 70 gram. It is 0 degrees Celsius. Very cold. Suppose you kept it in freeze. Okay, so this much. Now again the temperature become 100 degrees Celsius. 100 degrees Celsius means hot boiling water. How hot it is? Okay, difference is almost 100 degrees. 100 minus 0, 100 degrees Celsius. Hot it, like a boiling water. This much temperature the object has now. And in that situation, the volume always increases. How much increases? 50. It has gone up to 55 centimeter cube. Understood? At 0 degrees Celsius, 0 degree Celsius, how much? 70 gram
70
and
gram,
50 centimeter cube, 1.4 gram per centimeter cube of that matter. Density at 100 degree Celsius, m by v, 70 gram, mass is same. We are taking the same liquid X, and then in that case the density will be 1.27 gram per centimeter cube. Understood? Okay. Did you know Earth has highest density amongst all the planets in solar system? Its average value is 51,500 kilogram per meter cube container. So these are the numerical problems. Hope you have understood a little bit on density. Density means the matter contains. How big, how small is not important. Not defined by density. Density defines how much matter contains in a particular volume. Okay. So next we'll discuss this solution. We'll check it. Then we'll go for speed. This is also very important. Okay. Thank you.